I'm very disappointed with the lack of modernist robot uprising. Michael Reeves, Kakashi Hatake. Hi, I'm Kakashi, and today we're gonna talk about forced labor, aka Robota, aka robots for industrial automation. Little dark for a name in it. Well, that name wasn't my idea. This guy coined it, and this guy made it popular. This gentleman was famous for his Wolverine like beard, and also he's known as the father of robotics. He offered us three hardcore laws of robotics. Nevertheless, let's do it. For processes that don't require a human to decide how to do it every time, we can use a robot to do it automatically. Well, what is a robot? Software controlled mechanical device that uses sensors to guide one or more end effectors. Or it is just some parts connected to some motors, and the motors are controlled by some controller, which itself is blind and dumb. So we are giving it a program to follow and some sensors to see what is around it so that it performs some specific work. Well, say you decided to buy a robot for your factory. Good. If you buy a robot from ABB or other companies, what you will get is a robot manipulator, which means the robot accepts the part which is actually going to interact with the environment. That part is up to you to decide. You can fit either a gripper or a tool or whatever that you want on the attachment at the end of the robot. Whatever you fit there is called the end effector, and as the name suggests, it will be affecting or interacting with the stuff at the end of the robot. Fine, now what? There is just one thing left, and that is programming. Programming your robot with the action that you want to perform. The action is mostly about covering a path while operating the end effector at specific times. How will you give a path? It's simple. We will just give a certain points that our end effector should go through, and the controller will automatically fill the rest of the path. Very cool, right? No, I joined in a core company specifically because I don't want to do program. And now you're telling me to do that? That too after I spent money on this robot? Calm down, comrade. You don't need to do programming. Instead, you get to play with a joystick. This is what you will be doing as an operator. You will use the joystick to move the end effector, and then you will press a button that will store the point. Like that, you will store a sequence of points, and your job is done, which is what we'll be doing today. We'll control an industrial robot, virtually, of course, using ABB Robot Studio. So let's start with Robot Studio, shall we? Let's open this. So this is what the interface of Robot Studio looks like, and we'll work with this one today, solution with station and virtual controller. So the software solves all the kinematics equation for every move on joystick, which is known as solution. Station is basically a place where the work is done, and the virtual controller is a controller which controls. It's basically a joystick, a virtual joystick, which we'll get into later. Here you can name your solution. Solution 70 work for me for now. And robot model. Here you can pick up your robot model. So for today, or maybe for this entire series, we'll work with this one. Why particularly this one? This particular robot, IRB 1520 ID, is used for arc welding, and it's a 6-axis robot. It's highly precise. So let's create our solution. Let's first set up a nice view for our robot, shall we? You have three types of motion here: zooming in and out using the scroll button. You can use your scroll button to zoom in and zoom out respectively, and rotating around the robot, aka orbiting, by clicking down both the right mouse button and the scroll button, and then drag. Here you can rotate your robot, and it's a bit fiddly, but you'll get the hang of it. Then panning, aka moving left, right, up and down, is done by holding the control button plus the left click and with the drag. If you don't have a mouse but you have a numpad, you can do it using the keys 2, 4, 6 and 8 for orbiting, and control plus the same keys for panning. And if you don't even have that too, tough luck, bruh. Remember I told you that end effector that you will attach to the robot, it is attached right here, this place. Moving that will be our goal. So yeah, we'll work on that. And it is time we take a look at the controller, aka teach pendant or the flex pendant. It's basically joystick. Look at the menu on top. We are in the home tab right now. Let's go to controller tab and we'll pick our flex pendant. It's IRC5 flex pendant. It's just the model name. You can get this flex pendant for real in stores. So for now, we'll work on the virtual thing. But there's a thing, guys. I can't see my robot. How am I supposed to visualize it? So for that, let's try to drag it. And let's try to put our robot in a position where we can access both of the things. I guess this will work for me, right? Great. It depends on the software. Sometimes you get a teach pendant which is smaller in size. Sometimes you get a bigger one. No issues. So basically, there are 3 modes of operation which we can see by clicking this little icon over here. It's called control panel. Let's see it. The first mode which you can see is called automatic mode. In this mode, the robot will be executing the program we supplied to it automatically at full speed. This next mode is known as the manual mode. In this mode, we manually control the robot and create the programs. Also, the movements of this manual mode will be slow to prevent any accidents. This third mode over here is known as manual full speed mode. This full speed mode will do the exact same work as a manual mode, but with a full speed, 100% speed. So let's put the operation mode as manual, and probably you can see this white blinking button over here. It is known as motor engaging switch. This will be used to switch the motor and robot on or off. Now you will be asking how to know if the motors are on and off. Well, that status is shown here. Currently, the robot is in guard stop state, which means it's stopped. Of course, we need motors on state, which is done by clicking on this little guy here. By enabling it, the communication between the flex pendant and the actual robot is enabled. A little warning, there is a possibility that sometimes the enable button doesn't put the guard stop off. Don't worry, it's just a glitch. You just have to switch that enable button off and on again and it will work perfectly. So I guess we enabled everything. All right, we have enabled the controller, put the robot in manual mode, and we are all set, people. Joysticks, everyone's favorite. How to use it virtually? Simple. You can see the different arrows, right? Clicking on them moves the joystick in the direction. We have 3 independent directions to move it: up and down, right and left. And then twisting it. These 2 are for twisting it. With all that, let's see what happens when we do it. Did you see that? It is working. Hope you're all doing it too. Play around with it. And of course, pressing the diagonal arrows is just gonna move the robot in both directions at once. Let's try it. Great, you can see it, right? It's quite acceptable. Pretty simple, right? But stop. Safety first. What happens if you just made a program and while running it, some idiot decide to put their head in the way of the robot? Oh no, it's time to save him. Don't suit up, instead just press the emergency stop button and the robot will halt. And you can see the status changing to the emergency stop. If you want to restart it, just follow this order. release it, enable it and disable it. Just go on the motor and enable it. There you can see the motor is on again. And now you can enable the controller and start using the joystick again. Let's try using it. Great. So it's still working. It started working again. Good job. You learned a lot of stuff. Now relax. Hey, do you know that what you just did was called jogging? And also, do you know that there is a bunch of settings related to jogging? Let's see that too, shall we? Let's open the jogging window from here and click on it. Whoa, that's a lot of settings. Let me just show you some of the important ones as of now. And look at these angles, right? Remember when I said this robot has 6 axes? These are the 6 axes. They are the angles in which the axes are rotated from their normal location. When you use the joystick, these angle changes. Let me demonstrate it. Great, can you see the axis 1, the angle there keeps on changing. Now it's increasing and I can decrease it and keep it as 0 again. Great, it's almost 0. This system over here is known as coordinate system. This is another setting which tells the controller with respect to what axis we are describing the system. Did that just went over your head? No problem, you'll get it later in this series. Just know that the word coordinate means we are measuring the robot's joint angles with respect to the coordinate system connected to the ground. And there is another with respect to the end effector. Here is the important setting. Remember this one, motion modes. This setting decides what the joystick will actually control. We clearly saw that at the time we just have 3 independent directions, we can move the joystick in. This setting will specify what axes are going to be controlled by these 3 directions in the joystick. Let's see what options are here. Let's click on it. 4 options we have. We have the axis 1 to 3, which let's try it. Let's click OK. So it was by default this one only. So basically, this will let you control axis 1, 2, and 3. How do we know what direction in the joystick is controlling what axis then? Simple. Do you see these indicators in the bottom right corner? This gives you the information. Let's try it. Let's click on this down button and it's moving the second axis. Let's do this. And we are moving the first axis in the both direction. And let's try this one at last. Okay, it's working. Now let's change the mode and try to click on this one, axis 4 to 6, and let's see what happens. We should be able to control the axis 4, 5, 6 using the joystick. Let's try it. Great. Let's try this. Yes, it is working. For this one, let me give you a clear look. Let's see it. And yes, it is rotating. Okay, that is it. We are done. Or are we? Well, sometimes it is just inconvenient to control by robot access to get to a point. Say what if you want to move the end effector on a single line? Well, in that case, we have another 2 settings. You might have also noticed that there are 2 more motion modes. These modes are called linear and reorient mode. These modes are not concerned with the individual axis. These are concerned about the end effector's position and the orientation. Let's put it on linear mode as of now. Let's click OK. And first let me just make it look clear. One second. Great. Let's get back to linear mode. Now we should be able to move the end effector in X, Y, and Z axis instead of individual robot axis. Let's try it. Great. Well, before, when we were controlling the axis individually, the end effector's position was forming an arc. But now you can see clearly that the end effector is moving in a straight line. That is, several joints are moving at the same time. Now, what if we want to change the orientation in which the end effector is approaching the target. Well, for that we have reorient mode. Let's switch to that and see what it does. Let's try to use it. I'll just zoom in for a better look, and great. So this mode maintains the position as constant and rotates the end effector, and thus it changes the orientation. So we're done, right? So that is it, guys, right? We are done with this video, I guess. So I gently advise you people to play around with the joystick a little bit, and in the next upcoming videos we will see how to convert all these motions and to store it in a program which then can be automatically repeated by the robot. So that's us signing off. Keep the productivity level high unless you want to terminate under your bed tonight. Just kidding. Adios.